The game of pool was initially created in the 14th century as a yard game in France. It then evolved to the game we know as pool or billiards that is played on a felt table, and it consists of two players using a stick called a pool stick, shooting a ball called a cue ball at other balls down table. The balls that are being shot at are solids and stripes in order to differentiate, with another ball there being called the 8 ball, which is black. There are 15 balls in total, and to start the game, the balls are racked together in a tight triangular shape. The cue ball is then shot from the other side of the table and shot down table to break the balls apart. And one player nicks a ball into a pocket, declaring that as their color, either solid or stripe, and then they continue to make shots until they have no other color left. Finally, the 8 ball is shot and is made into one of the declared pockets, and that how the game of pool is won. There are many other factors that involve physics in them, but that is the general overview of how this game works.
In order to start this game, you must put chalk onto the cue. And you must be thinking, well, why am I supposed to do that? Well, there's a very important reason for that. And that has to do with the relationship between the cue and the ball. You see, the cue is a very slippery surface on the end of it, and so is the ball. So if you were to hit the ball with your cue without any sort of friction, i.e. through chalk, all it's going to do is it's going to miscue and not go the way that you intend it to. And also a very important aspect to chalk has to do with the fact of spin.
So spin is used in a variety of ways. It's used in the forms of topspin, backspin, and side spin. Topspin is used in order to pull the ball forward such that the ball is rotating faster than it is traveling linearly. And the ball having backspin means that the ball is rotating faster backwards than it is going linearly. Side spin is a whole different animal, so let's first focus on topspin and backspin. Topspin is used such that after the ball transfers all of its momentum to the next ball on the line, it will continue to spin in a forward motion to place the ball in a better position. Backspin is used similarly to where after the ball is done having linear motion, it still has friction with the felt such that the spin pulls the ball backwards. So that felt friction is very important because it allows the ball to gain traction and move separately of the linear motion. In addition to this, felt friction is used in the side spin. Side spin is where the ball rotates from one axis to the other on the side. So there can be positive rotation and negative, while the ball moves in a straight or curved line depending on how extreme the spin is. Side spin is used in order to create a better hit on the ball or get around a ball that's in the way. Side spin is difficult to do, but it is very well implemented and is aided by the felt friction. As the ball grips sideways on the felt friction, it allows that rotation and the motion that is hit. Creating spin is worth nothing if you can't hit the ball, so you need to be thinking next about how you're going to hit the cue ball against the ball you're attempting to hit. So in order to do this, you're going to look at the ball you're going to hit and imagine that it's an elastic collision, because it is. While it's not perfectly elastic, it's very nearly elastic, and what that means is that almost all the momentum is going to be transferred as well as almost all of the kinetic energy, which means the next ball is going to move at almost the same speed as the one previous, because all the balls are the same mass. So how this collision occurs is that one ball will hit another and glance off it, or go straight ahead. And when these balls glance off each other, they usually glance off at around a 90-degree angle perpendicular to each other, as the vectors do. And the ball hit will travel off with the majority of the velocity, while the ball traveling in a straight line will continue with the rest. Because this is an elastic collision, most energy is conserved, so that's what that involves. I did say that this was mostly a perfectly elastic collision because no collision in the real world can truly be perfectly elastic, and what can be seen as lost in this kind of a collision is in the form of heat, sound, and sometimes friction between the balls. In addition to collisions between a single ball and the cue, there are also collisions between multiple balls. This occurs in things such as the break, which we discussed earlier in the intro, and when all the balls are all right against each other. So the energy will be transferred from one ball to the next ball to the next ball to the next, until it eventually travels through all 15 of them. These collisions are all also almost perfectly elastic, as you can't have perfectly elastic in the real world, and they occur in a similar manner to where the vectors all go at perpendicular directions. It's becoming a common theme here, but bumpers are also on nearly perfectly elastic collisions. A bumper is the side of the table and it's rubber, and it gives it the ball bounce back in a angle that is supplementary to the angle that it approaches with, such that you can glance the ball off and create a more complex shot. So this would be used in cases where the balls, you can't reach the ball, and it allows for a more complex shot, conserving most of the momentum and most of the energy, as some is lost in the form of friction between the wall of the pool table, which is covered in felt, and the ball. And there's something called the coefficient of restitution, which is generally used in order to measure how much of the energy is going to be conserved in a collision. So because this collision is not perfectly elastic, there's a coefficient of restitution of about 0.8 or 0.9. So what that means is, as with many things in physics, the closer to 1, the more perfect it is. That's the same thing here. So 1 is perfect, has a perfect coefficient of restitution, meaning all of the velocity is conserved from the initial velocity of the collision to the final, whereas our coefficient of restitution in this case of 0.8 or 0.9 means that about 80 to 90% of the initial velocity is conserved with our cue ball.
So what did we learn today from learning about pool? Well, as you can see that we learned about the physics behind it. We learned about felt friction, why that's necessary for pool, why we need chalk to use it. It's also important to understand the different techniques, like for example, back spin, side spin, and forward spin. It's also interesting to note, the different type of collisions you can have with bumpers as well. There's so much to the topic of pool, and we've only scratched the surface of it. And I want to leave you, viewers, looking at this video and saying, hey, this is kind of cool. Like, I want to be inspired to do more physics because of this. And so, yes, this is a good food for thought, and I hope you guys enjoyed the video.